Hello everybody! When you're building a class library or website in .NET Core on an Azure DevOps pipeline, you want to be in control of the version number assigned to your DLLs, don't you? This is Stef from Samayas and welcome to my channel. In .NET Core, in the CS profile, we defined a version hard-coded. In the old .NET versions, we could still use an asterisk, and then we got a version where the build number were the days since the year 2000 and the revision the second since midnight. However, .NET Core doesn't support the asterisk anymore, at least not in the CS file. There are other tricks, however. In .NET Core, in the CS file, we have 4 different kinds of version elements. The assembly version controls the runtime binding. This is the version which is used between .NET libraries. If, for instance, your library is looking for version 1.2.6.0, this is the assembly version that it defines. It is not required. If it's not present, it will take the version element, and if that one is not present, it will fall back to 1.0.0.0. The file version is the version that is shown when you click on the properties in the Windows Explorer, and is just informational. If it's not present, there's a fallback on the version element. And if the version element isn't present, again, it defaults to 1.0.0.0. The informational version is for display only and can use text and version information or a combination of both. Again, if it's not present, as a fallback on the version element, or again, it defaults to 1.0.0. And finally, we have the version, which is default if all others are omitted, and technically it's also not required. If none of the version information is present, everything would fall back to 1.0.0. And finally at the bottom, we have the package version, which is used should we also create a NuGet package from our component. Again, if that's omitted, automatically there's a fallback on the version element, and with that omitted, again, we fall back to 1.0.0.0. Now if we look at the Microsoft libraries as packages, for instance, package 9.0.6 from NuGet, if we dig inside, the DLL is also having version 9.0.6. However, if in the File Explorer we look at it, we have a version of 9.6.625.26.607, which doesn't really refer to the old syntax from the .NET old version, so we clearly have a build number and a hotfix which defines something, which is probably internal logic. This might be helpful to know at what time a library is built, since if we copy a DLL and we recreate another system, the file stamp won't be correct anymore. However, for our .NET components, the only version that's really important is 9.0.6. Now out of the box, our CSproj file determines which version is outputted. And it's up to us to control what version we want and where. In Git, that version won't move unless you choose to. So I want to have an automated system in my Azure DevOps pipeline, where in every build, I want to increase in an automated way to the next version. For a web project, this is less important, but it's still quite handy. For a component library, it's much more important, so that every time when I release a new component, I automatically have my new component and my package with version +1. So some years ago, I've created an Azure DevOps extension that will just do that. It's called Build Version Updater. Basically, inside my pipeline, I have a predefined variable that at the end of every successful build is incremented by 1. That could be a build pipeline, but also a release pipeline. Now, of course, I'm not the Microsoft of the world, and I don't work in a team with 2,000 persons on one release. So every time I make a build and a release, I update my build number, +1. So on a busy project, I might get up to 200 on a build number. If we look at the .NET releases, well, there's a release every couple of weeks/months, and it only adds 1. So for that, that's probably not the right choice. But let's dig in. So if I created again a beautiful test class, I have one helper method with a static help me method, and that's it. In the test class itself, I have the basic properties. So now let's build and look at the result. So if we look at the bin debug directory, we have one DLL. We have specified nothing on versioning. And so what do we get on details? Well, we get version 1.0. And if we look in .peak, we also have a test class with 1.0. Now if I put in minimal versioning and I rebuild this, if we now look at properties, we have the file version, which is 1234. We also have the product version, which is 1234 plus something. And if we reload it in .peak, we also have 1234. Still quite easy. Now if we still have the version at 1234, but we add informational version, which is just a string, which I call development build, and I put the file version in 1235. Let's rebuild. If I now look at properties, my file version is 1235. My product version, which is equal to the information version, has become development build, and .peak stays at 1234. Now let's add assembly version, and let's see what that gives. And my file version still stayed 1235. Now we have the version, but the assembly version is overriding the .NET version. The information is overriding the text, the file version is overriding the file version, and so the version is technically only used for the NuGet package. So I've added some NuGet properties so that this also generates a NuGet packet. And if we now look in directory higher, we have a test package which still uses the version. And so here the version is still 1234. Now in general, NuGet package should only have major, minor and build. So let's override that by 2.1, and if we rebuild this now our package is using the package version. And so technically the version is not used anymore. Now let's prepare this for Azure DevOps. And so now in general, this is what I define in most of my packages. I define the version 2 times. The first version is when I don't have a build number, and so I'm not running in Azure DevOps, and so I have a hard-coded version number. If I am running in Azure DevOps, then I'm using a variable which is called project version number. For information, if I'm not in Azure DevOps, I just put development build. If I am running in Azure DevOps, I put release build and I put the build number next to it. And for the package version, if I'm not running in Azure DevOps, I'm just specifying the version number. If I am running in Azure DevOps, I'm specifying the project version number. And so my test class is ready for Azure DevOps. So now we have our Azure DevOps pipeline, and I've already created a pipeline and I've got already a successful build, and I've named it demos since in my demos project. I've called it Azure DevOps version. I have CI, I have a build number, and I've got a version number already. As you can see, it's version 2.0.15. But wait a minute, did we not specify version 1.0? Well, if you go back to the repo, indeed, we did specify version 1.0, but only for development. In Azure DevOps, we are taking project version number. So let's go back to the pipeline. If we edit this pipeline, it's a very simplistic pipeline. I have a .NET build. I call the build command. I take all csproj. As configuration, I pass build configuration. If I go to variables, in build configuration, I specify the release. So this build will always be in release. Once the build is done, we have an DLL and a NuGet. And then we do a simple copy, where we copy all NuGet packages that we find, and we copy them to the artifacts staging directory in the NuGet directory. And finally, the publish takes it in the artifact staging directory NuGet directory and publishes it as an artifact. If we now look at the build release under published, as you can see, we have one consumed item, and in drop folder we have a test package with version 2.0.15. So our job is done, right? Now how do we get to version 2.0.15? Well, under variables, I first have specified project prefix version 2.0, which is the major and the minor, and then I specified project build number, which is the variable which will be increasing to 15. And then finally, I specify a new variable, project version number, which is a concatenation project prefix version number and project build number. And so the variable you see in the csproj file is this one. And the goal of my extension is to every time a build is done, by magic, well not really magic, just update that project build number. And then finally, project version number is also used under the options. Here, By specifying the build format number, we have the build definition name, we have the date, we have the project version number, and we have the project build number. And the concatenation of this, in the end, gives us this long string, which immediately allows us to identify when it's built and what the version number is. So now I've gone to the Azure DevOps Marketplace. In here, you can just search for Samayas. And so here you can see I've created 3 Azure DevOps extensions. Today, I'll be talking about the build version updater. And if you click through, you have a complete description of how to use it and how to configure it from A to Z. So if you want to use it, you need to go all the way to the top and you need to click the Get It for Free, and automatically you can either install it in your online version or you can download it for your own Azure DevOps server, which I'm running locally. And so when you're done, you get this page. Of course, this only works if you have the necessary administrative rights to install extensions in your organization. If you now go to your general collection settings on your Azure DevOps server, you get a screen which is something like this. And then you have the extensions tab, and then you should see all the extensions which you have locally installed on your server. So if the build version updater extension is in the list, you're on track. If you click through, you can see which version is installed and what are the previous versions you might have already installed. So now let's return back to our pipeline and let's install build version updater. I click on the add, and here build version updater should be visible. And here we have it. We just click on add and now we need to configure it. So the display text you can modify. By default, the variable is defined as project build number. And then we need to configure a connection to our Azure DevOps server. If you already done that, you'll have something in this list. If not, you need to create a new one. And so for this, you need to provide a personal access token, a service connection name, and a description. So the service connection name is easy. That's just a name, and a description, some extra documentation. However, we need to get a personal access token. And here it gets a little bit complicated. So let's go back to the documentation. And so as the documentation states, you need to go to your profile, and there you need to go to security, and there we need to configure a number of things. Either you can choose full access or we can go for custom defined. If you already have a personal access token which has full access, you can reuse it. However, I prefer to use a personal access token that can just do what it needs to do and has no extra rights. And so the rights which I needed for this extension is the build, read and execute, and is the variable group read, create and manage. So let's do that. I close this one, I go to security and I will leave this page. And so in my personal access token list, I click new token, I give it a name, build version updater. I need to choose my expiration date. I'm going to put it as far as possible because that's something I've always forget. And as far as possible is about 1 year down the road. And I'll leave it custom defined. I select show all group. I select show all scopes and I scroll down. And we need, let's go back, we need the variable group read, create and manage. So I have the variable group read, create and manage, and we need to build, I've missed that one, read and execute. And finally, depending on whether or not you can choose your organization or you can choose all organization. I'll just leave it on this one and I click create. And so now here I have correctly created a token. I need to copy that token and choose close. And now I have my token. So now let's return to our pipeline. And of course, since I haven't saved, everything is gone. So let's restart. Let's add. I add that again. I click on it. And this time we can create our server connection. So let's do that. New. I copied the previously copied access token and I give it a name. And here we can choose whether or not we grant this service connection for all pipelines or I just want it for this. For now, I'll leave it like that and I'll click save. And so now we should have a working build updated version. It refers to the variable project build number. And if you go back to variables, here we have project build number. So now let's save and queue. And as you can see, the update has been completed. So technically we still built version 15, but if we do an edit again, since it's at the end of the pipeline, if we now go to variables, variable has been augmented by 1. So if I requeue now, I will have a version 16. And if I now go to my builds, well, previously I had two 15s and now automatically I have a 16. And so we finished the installation of build version updaters. So implementing this solution, of course, is quite easy. You just need to include it at the end of your pipeline. But then again, there's never just one solution to a problem. And one that might suit some people will not necessarily suit everybody else. If you guys enjoy this content, please give it a thumbs up, subscribe to this channel and hit the bell sign. Or leave a comment down below.